Okay, so in this program, I'm going to go over the initial code I'm giving you guys for the breadth first search algorithm, and you will extend it for the things that I asked you to do in this quiz. So it's going to input three values. The first is the number of nodes in the graph. The second is the name of the graph file, and the third is actually the starting node from which you want to run the breadth first search. Okay, so I get them as command line arguments, args of 0, 1, 2. So the first is an integer argument for the number of nodes, so I have to typecast that using to an integer. So I say the integer dot parse int of args of 0 is going to convert that string that you get in args of 0 to an int value, that is the number of nodes. And as we saw in the tree map example, you're going to initialize the tree map called netinfo to basically empty vectors. So tree map netinfo is new tree map, and I run the for loop for id equals 0 to id less than num nodes, because each graph that is assigned to you is going to be something like from 0 to certain number of nodes, in this case 7, so it is totally 8 nodes. So we will input 8 as the args of 0 to the user, and it will run from 0, 1, 2, 3 up to 7, and each one is initialized an empty vector, and you're going to populate that with the neighbor nodes for each node. So you're going to have 1 and 4 as the neighbor nodes of 0, then 0, 2 and 5 or as the neighbor nodes of 1, and so on. So each will be stored in a vector. Okay, so I am going to now read the file graph information from a file. So this is my file, so it has this graph information, so you need to store the graph information as a file. So it has 0, 1, then 0, 4. So you're going to run it from top to bottom, and the first ID is always going to be less than the second one. So 0, 1 is the edge, then 0, 4. In the case of 1, you don't have to say 1, 0 because that's already taken care of in this 0, 1. So in the case of 1, it will be 1, 2 and 1, 5. Then in the case of 2, you don't have to take care of 2, 1 because it's already taken care of in the edge 1, 2. So you will write 2, 3 and 2, 6. Then for 3, you don't have to say 3, 2 because 2, 3 is already there. So it's just 3, 7. So as you can see, as you go down, every time the first ID is always less than the second ID. Then in the case of 4, we already have 4, 0 taken care of. So it's just 4, 5. In the case of 5, it's going to be just 5, 6 because 5, 1 is already there and 5, 4 is already there. So it's just 5, 6, and in the case of 6, it is 6, 7. So for 7, you don't have to say 7, 3 or 7, 6 because both are taken care of already. So this is the adjacency list that has all the edge information. So we're going to read this. So make sure the last line is this. So don't press a blank and have a blank last line. So make sure this is the last line and save it. So I'm going to read that file line by line. So I have the file reader that gets a file name. So the file name is args of 1 input by the user, and I'm going to read line by line. So I initialize a line string as null, and I'm going to have a buffered reader that's going to read line by line from the file. And I say br.readLine, the buffer reader object br.readLine is going to read one line from the file and store it as a string line. So I continue to read that until I read a null, basically until I reach the last line. So each of those lines is a string, so which is basically this 0, 1, 0, 4 and so on. So 0, 1 is a string, a line, 0, 4 is a string, another line, 1, 2 is a line, 1, 5 is a line, and so on. So we know that this string has like two integers in it, separated by a blank or a tab space, it doesn't matter. So I say a string tokenizer stk equals new string tokenizer of line. So it's going to pass this line into tokens, and we know there are two tokens in each line, two integers. So I say stk.next token, and each token is also a string. So stk.next token is going to return the first string, which is 0, and we're going to typecast that to an integer and say it is uid. And stk.next token is going to also return a string, which we are going to typecast an integer, so that is vid. Now we have created an empty vector for each of those integer nodes, basically uid and vid, or the nodes or the vertices in the graph. So when I say netinfo.getUid, it is going to return an empty vector initially to start with, and we're going to populate it as we read the file. So it's going to return the vector of neighbors of uid, and it's going to return the vector of neighbors of vid. So I call them as u neighbors and v neighbors, and we check if vid is already a neighbor of uid. So I say u neighbors dot contains of vid. It's going to return true if vid is already listed in the vector u neighbors. If not, so it's going to return false, and not of false is true. So you come inside the if statement, and we are adding vid to u neighbors. So basically we want to make sure that node is added as a neighbor only once, which will be the case if we create the file like this. But if, let us say, by mistake I entered 1 0 also as a line, it's not going to add a node more than once as a neighbor. So that's why we are making sure this takes care of that. So same thing, we check whether uid is listed as a neighbor of v. So if it's listed in v neighbors already, we're not going to add it. If not, we're going to add it. So this way we're going to read the file line by line and get this vector of neighbors to be filled up for each node. So we can really come out of the while loop, and then run a for loop that basically goes from id equals 0 to id less than num nodes, and it reads the so netinfo.getId, it's going to get the vector of neighbors for each node, and I can print id and the vector, the value, the neighbors list for each node. So this is, up to this point we are kind of reading the graph file and and kind of learning the neighbors of each node. So now we are going to run the breadth first search algorithm. So for this I make use of two vectors called the FIFO-Q. So this vector will keep track of the nodes that have been visited but whose neighborhood is yet to be explored, and nodes visited is going to just store the list of all nodes that have been visited as part of breadth first search. So the starting node of breadth first search is something that the student or the user can input, and in this case that will be the third argument, args_2, which is again an integer. So I typecast that args_2 as string to an integer, so it is stored as start node id. So from that, this is the node from which we'll start breadth first search. So we will add that to the FIFO-Q as well as to the nodes visited. So I'm going to run this while loop. So as you know, breadth first search runs based on a queue. So I'm going to run this while loop as long as the queue has at least one integer or one value in it, basically the node ID. So I say FIFO-Q.size, which is a vector, so it's going to return the size of the vector. I'm going to run it until it's greater than 0. So to start with, the size of the FIFO-Q is 1 because we added the start node ID before we get into the while loop. So it will be of size 1, so we can get inside the loop because 1 greater than is 0. So once you get inside the loop, you are going to get the first element in the loop, in the queue. FIFO-Q.get0 is going to retrieve the first element, which is again an integer, so we need to typecast it an integer and dot int value. So that is the current node ID where you are running the breadth kind of at some iteration of breadth first search basically. So once we retrieve that node, we can remove it from the queue, and now we can, so remove 0 is going to be basically removing that first node that we removed, that we just retrieved from the queue. And so netinfo.get current node ID is going to retrieve the neighbors of that current node ID. So I call this as a current node neighbors. Now I'll run a for loop that goes through the current node neighbors one by one. So I use this index to go through the entries in the current node neighbors. So I retrieve each node in the current node neighbors vector by using current node neighbors dot get of the index, and that's again an integer value, so I kind of have to transform to an integer. So it's the neighbor ID. Now I need to make sure that neighbor node that I just traversed is not yet visited. So I check if nodes visited this vector contains neighbor ID or not. If the neighbor ID is not in the nodes visited, which means I have not yet visited that neighbor node. So this is the first time I'm visiting the neighbor node. So I add that to nodes visited vector, as well as I add it to the FIFO queue. So if the node has been already visited, we are not going to go inside the if statement and add them to the nodes visited and FIFO queue. So that is it. So we do that repeatedly, and the next iteration, some other node which comes to the beginning of the queue after the removal of the earlier node will be extracted from the queue, and its neighbors will be explored, and so on. So with that we stop, and there will be some questions asking you to extend this code to whatever has been asked for you. Okay, we'll stop with this.